Welcome back to Altengrad City in City Skylines. Today we will talk about concrete and manufacturing of concrete prefabricated panels that will be used to assemble the large residential blocks. And I'm of course talking about the mass housing projects that would drastically change the looks of many Central European cities. In the background, I'm going to be building a panel factory on the outskirts of the city, in the area roughly beyond the exhibition center, at the railway junction conveniently close to the cement factory from last time. This build is heavily inspired by a real-life factory from Zwickau in East Germany, as I was able to find enough historical photos and aerial views of it. So let's start with the building. Concrete prefabrication plants started to pop up in larger and smaller cities all across Central Europe, as soon as the central planners decided that concrete prefabrication will be the primary technology to construct the massive residential projects. I would like to skip the detailed background for this decision for now, to only focus on the factories, panels, and related technology. But in the following video, we will talk about the theoretical backgrounds for post-war housing ideas, urban planning, and so on, where it will be put into a general context. In short, the prefabricated panel technology was cheaper, and buildings could be built much quicker compared to brick houses. Also, the prefabrication was conveniently in line with the principles of industrialization, unification, and rationalization in the construction sector, like we already talked about it in previous videos. If you want to make a concrete panel, you need concrete. So what is concrete? The very basic components are cement, water, and filler. The fillers are various sands and/or gravel, commonly called the aggregate. Since cement is by far the most expensive part of the mixture, you want to use only a small amount and fill the rest of the volume with the aggregate. But at the same time, you need certain mechanical properties, like strength, which comes from the cement, so you need to balance it. Water is added to chemically react with cement, so it produces the hardened material, but you don't want to add too much water because it reduces the final strength. But you need to add enough so you are even able to mix it and pour the fresh mixture so it nicely fills all the corners and details in your molds. So there needs to be a balance here too. When we go back to the aggregate, there is also the need to have a proper distribution of grain sizes. When designing concrete mixture, you will usually know what maximum size grain you can allow. Prefabricated elements are usually more finicky to pour, so the maximum grain would need to be small, so that the fresh mixture can get into all the small places and details. Why not just use very fine sand and not deal with this at all? Well, because small grains are more expensive. That's why you want to use the larger grains as much as you can, but you cannot just use the large grains. So properly designed concrete mixture that efficiently uses its components for maximizing strength and minimizing costs use different fine silts, medium-sized sand, and coarse gravel in very specific ratios. So overall, it is complicated. And this was just pure cement, water, and aggregate. But in modern concrete, there are many more admixtures that also need to be balanced with everything else. One interesting thing about concrete is how it relates to science. For the most of human history, various types of concretes were used even when the engineers had no idea how it works. It was simply discovered that when you mix water with certain materials, it hardens. And since these materials were not that common, larger rocks were added to fill the volume. Ancient Romans already did this. In the 19th century, in Britain and France, some scientific progress was made with cement and concrete, but it was all mostly based on previous experience and trial and error, although some theoretical work was also done, which later proved to be true. These advances were enough to use concrete to build high-rise buildings or dams. But it wasn't until the middle of the 20th century when science really started to dig into this topic. And that is the time period that material engineers consider the start of modern concrete technology. The chemical processes of concrete hardening were confirmed from previous theories and further explained. The crucial role of the microstructure was identified, and based on that, certain new admixtures started to be used. All of this paved the way for more suitable concretes for prefabrication and various manufacturing techniques. So, while we tend to see concrete as some ancient material, it was not that long ago when we finally started to understand it. And what's more important, the prefabrication factories that started production in the 50s in Western Europe and later in Eastern Europe were all using cutting-edge technologies in this regard, not some well-established, well-known processes. So not only were the prefabricated buildings and their urban designs an experiment, so were the materials and products. So that was a brief introduction to concrete. Now let's go over parts of the panel factory to talk about the panel making process. At the start, you need to bring in the raw materials. This was usually done by a railway, so panel factories were established in existing industrial zones or at the very least near existing railways. Cement was transported using special wagons because it couldn't get wet and unloaded into silos. Aggregate was usually stored in very large bunkers in the open as it was needed in very large amounts. This means that it could get wet, which is not exactly desirable, but it's cheaper than to just build some huge silos for it, transport it with covered wagons, and so on. But it also means that you now must know how much water it contains so that you subtract it from your calculations of water added during mixing. And this is not exactly all that easy thing to do. Alternatively, aggregate can be dried before mixing, but that is expensive and time-consuming in large-scale production. The bunkers and cement silos are connected with conveyor belts into the part of the factory with a mixer. Factories usually have a very large mixer to mix several tons of concrete all at once. The fresh concrete is then distributed inside the factory and poured into the molds. And the molds is where the whole process gets really interesting because they are not just some primitive wooden boxes that you would put together to make a planter in your garden. They are fairly complicated steel contraptions that are very expensive because they need to be quick to operate, easy to use, and precise, at least theoretically. Some of the molds have hydraulics for disassembly, some are made for multiple panels, some can be rotated, move around the factory, and so on. At the start, the molds were covered in the molding oil, which prevents the concrete from sticking to the steel too much. Then all of the necessary things were put into the mold, most importantly the steel reinforcement, but also other things. Because the panel needs to be prepared for transport, lifting, assembling, and overall it needs to be finished after the concrete hardens. So together with the reinforcement, there needs to be various inserts blocking the concrete from flowing into some openings, holes, or edges where the reinforcement sticks out, so the panel can be hooked, lifted, and welded with its neighbors. With certain building systems, electricity was run through the panels. Ideally, a tube was put into the mold at this stage, so electricians could later pull wires through it. But in some cases, the wires were embedded in concrete directly, which unfortunately makes repairs impossible. But also in some cases, wires were not dealt with at all with panel manufacturing and had to be routed at the construction site. Ceiling panels sometimes had water tubes put into the molds together with the reinforcement, sometimes being the reinforcement. The tubes would act as floor heating. The French panel makers did this as well as Czechs, but in case of the Czech system, it was only an experiment in the late 1950s, and it wasn't used after that, since it was impossible to do any repairs to the tubing, and the whole circuit failed rather quickly. I did not find any information whether or not the French also dropped this system later. After everything was prepared, concrete was poured in. The whole mold would then be vibrated to compact the concrete and force it to flow into every detail. Concrete is a thixotropic material, meaning that certain mixtures might just resemble dry piles full of voids or air bubbles, but when vibrated it starts to nicely flow. The pouring and vibrating might be done once or multiple times in layers. After that, workers would manually screed the surface and remove any excess. Next, the concrete needs to be cured. At first, this was done with the traditional approach of putting the mold aside for a day or two, then removing the product from it and just keeping it somewhere wet, spraying water on it, for example. But panel makers quickly adopted the steam curing technology. It means that the whole mold is put into a closed box with hot steam, between 40 to 80 degrees Celsius, depending on the technology and mixture. The steam curing has two major advantages. First, the closed environment with steam keeps the concrete nice and wet. Second, the elevated temperature accelerates curing. The disadvantage is mainly energy cost. Steam curing today is not that common anymore. What's much more common is the use of chemicals that accelerate curing. Some molds were made to be both molds and curing machines, so steam would be run through them already without the need to move the panel around. For how much time was the panel steam cured was up to the specific technology, mixture, and factory policy. It might be a couple of hours plus some more time, maybe a day in the mold, or it could be around a day in the box and then immediately removed from the mold. But in any case, after removal from the mold, the panels are stored. In case of these panel factories, there will be a huge storage yard with multiple gantry cranes outside. Some factories have the cranes simply along the whole manufacturing building, and the same crane continues outside parallel. The one we are doing from Zwickau had rails going from the buildings and cranes oriented perpendicularly. In the case of facade panels, panels that would have one side facing the outside, the manufacturing process would be slightly more complicated, depending on the prefabricated system. Some of the earlier prefabs simply had a thicker outside wall, sometimes made of concrete, designed for better thermal insulation, although barely. If the panel wasn't load-bearing, there are examples made of aerated concrete, which is not very strong as it has a lot of pores, little bubbles of air inside, but it does offer better insulation. Later, when it became clear that not wasting energy on heating might be a good idea, panels started to be made with proper thermal insulation, using the so-called sandwich configuration. Although here it must be said that this insulation is still nowhere near enough for today's standards. Windows would have also been put into the facade panels in the factory. It wasn't done for the earlier systems and some other systems later, but panels arriving on site with the windows done significantly helped the assembling process. The facade panels received various finishes. Some of them left the factories with just bare concrete because the final plaster facade was put on the already assembled building. This was the traditional approach to construction taken from the old brick buildings, but soon engineers realized that even the facade can be finished at the factory already, so the process of finishing the house would be even simpler. So the engineers got creative and came up with some really ingenious and modern approaches. One approach was the washing method. This would be done after the concrete was already somewhat set, but not totally hardened, and the workers would basically power wash the surface, which would wash away a thin surface layer of cement, but leave the aggregate exposed. This looks surprisingly good and requires minimal effort. It makes the surface look a little weathered. Another method would be just to lay the panel horizontally, and workers would put slightly larger decorative rocks or smooth pebbles on top, so they would partially sink into the fresh concrete, but not fully. These rocks would be selected to have specific colors and shapes, and it could have also been combined so that different panels on one building would have them in different colors and different sizes. This is my absolutely favorite surface finish. It really looks amazing. Here I took a couple of pictures of decorative panels from Hotel Thermal in Karlsbad that I mentioned last time, and this is exactly that. This original panel is a little scuffed already. The lower quality of some of these panels really shows. The cement matrix is not the greatest, but this example of a newly made replacement is really nice, how it also plays with different colors of the rocks, kind of spread evenly around the panel. In one of my previous videos where I showed the city of Ostrov, the prefabs near the end are exactly like that, but I didn't take any close-up shots, sorry. But there are also other examples from the whole Europe. This one is from Germany. It's a very common look for the newer prefabs. And this is a building from Aberdeen in Scotland, where, as you can see, they really went crazy with this technique and played with the facade a lot. They used some smooth concrete in some places, then smaller rocks evenly pushed into the concrete, and then the very large rocks sticking out, creating the very uneven raw finish. It makes it look like some kind of castle or something. It's really nice. Raw concrete was later used as well for the technology when the panel was poured vertically, so the outer surface was kept smooth by the mold wall, although this was not that widespread. Some types of plasters or paints were applied in factories as well, but unlike plasters applied at the side, with the pre-applied, the panel gaps would remain visible. Ceramic tiles were sometimes applied, that's what we can see on that German example from earlier, in this case combined with other types, but whole covered panels can also be found. Some French prefabs were made by putting rubber inserts into the molds with like a 3D tile structure to print that onto the concrete facade, creating some sort of fake tiling. And of course, other techniques and variations of these techniques were used as well. Not just panels needed to be prefabricated, but also stairs, various pipes, tiles, and other accessories. In total, the panel house would need many different types of panels. An early experimental Czechoslovak system, which aimed to reduce this count, had 24, which was considered very low. So there had to be 24 different molds, or at least different modifications of them. By the way, I really am using the words some or sometimes a lot. That is because I don't want to give you the impression that that's how every single panel or prefab building was made. Contrary to a popular belief that prefabs in the Eastern Bloc were all the same, they absolutely were not. Countries used different systems, and even regions or cities in those countries used their variants. Basically, every factory made slightly different panels. And the systems evolved over time. What I'm introducing here are some of the more common practices, but there were significant exceptions that would be almost impossible to completely map. Here I would like to stress that prefabricated concrete houses were built all across Europe in 1960s. It was certainly not limited only to the Eastern Bloc, so all of those comments like, ah yes, Soviet housing, when looking at any big concrete building is complete nonsense. But we will talk about the evolution and eventual differences between countries in other parts. One other thing to note is that this industry was relatively open. Engineers and architects were able to see what was done in other countries across the Iron Curtain and share technologies and methods. So one last thing that we need to do with the panels after they've been made is transport them to the construction site. This was a problem at first, so that is one of the reasons why fully sized panels were not used in the beginnings of prefabrication. Smaller blocks, not really called panels, would have been used instead, basically something like bigger bricks weighing several hundreds of kilos. But that proved to be inadequate, so engineers developed the common standard full-sized panels, weighing up to around 5 tons. Of course, even larger panels would have been ideal, as it would make the assembling process faster, but that was already too impractical. New trailers for trucks needed to be developed. This was something completely new, transporting very heavy stuff over roads like that, roads that were absolutely not designed for such loads. A semi-trailer truck was something rarely seen on the roads, but now it was the only way to move these panels. One truck could only transport 2 to 4 full-sized panels, and there are roughly 30 panels for one floor with 3 flats in the prefab system that we will be building in the next episode, but the numbers would be similar for other systems. So overall, that was a lot of rides. During the construction of some larger housing estates, it must have been one truck right after another leaving the panel factories. That's also why the factories were in all major cities as well as smaller ones. The demand was just too high and transport too complicated for the time. And lastly, let's talk about some common problems. The hardware of the factories was very complex and expensive to build. The initial investments into them were only justified because of the huge scales of the planned housing development, through the standardization and unification. This meant that any deviation from the standard panel was close to impossible. Some architects were able to do slight customizations, but only in a few projects, in the experimentation phases when some systems were new. Since the panels were factory-made, they were very precise and perfectly fitting together, right? No. The panels would eventually wear out and deform, as they were under a lot of stress, especially the moving parts and connections. Workers were not always following the correct practices, like tightening the molds or carefully handling them, which accelerated their wear. Fresh concrete was also not always placed correctly. Some buildings are known for having some reinforcement missing. We can see in the vast majority of old clips from construction sites how some of the panels have broken edges, exposed rebar where it shouldn't be, or some surface issues. Some panels arrived to the construction site even broken, some broke during manipulation on the site, so we can also often see discard piles of unsuitable panels. Examples can also be found where you can see workers chiseling the finished panels on the construction site so they would fit. All of this means that the systems were not even designed to be like Lego. I guess it was clear to the designers that tight tolerances required for such connections would not be achieved. Czechoslovakia and Hungary, for example, bought some precision hardware from Denmark to aid the local production. Nevertheless, the prefabs were built despite all of this, but we will leave the actual construction process for later. Alright, so that was the background for today's project. I really should not call it the introduction anymore because it was pretty much the bulk of the video, but I just want to mention that that's kind of how I would like to do it in the future, to focus more on that, like we did today, because it's kind of necessary, and I would really like to just go into slightly more details with some of these introductions, as it's kind of necessary and I really like doing that. So yeah, there it is, and that's how it's going to continue. Anyway, we don't really have that much time because of that in the time lapse, so let's just quickly sum up what I'm building here. So the factory is made mostly out of these DDR factory floors. Now, these are the buildings made by Meister Monis. They are absolutely perfect for these 60s, 70s factories, so I'm probably going to be using them some more. We have at least one industrial area that we need to revisit, that is the harbor, so I will definitely use them. And you know, that's very good because I don't really have that many different factory buildings, so more variation the better. So yeah, those are the factory buildings. Very straightforward work with those. And there's like a whole bunch of these in a pack, so you can just easily, you know, put them together, clip them together, create your different shapes and sizes and all those things. So that is very, very good. Alright, so like I mentioned in the beginning, this factory is inspired by a real-life structure in Zwickau in East Germany. I was using the aerial views that are found on the city's website. Unfortunately, the aerial view from like 1960s or something does not reach the edges of the city. The factory is built pretty much outside of the city, kind of. So I was only able to use some early 1990s photos, but the factory pretty much remained like that since, you know, those 60s, 70s time. I'm actually not sure when it was established, but when I was just looking at various other factories in Poland, in Czechoslovakia, they all kind of look pretty much the same. This one in Zwickau was probably the largest though, so that's kind of why I chose it. And it had the interesting configuration of the bunkers, the storage for the aggregate, and the gantries, the cranes and all of that. So that's the reason why I took that as the inspiration. The factory is still standing today, by the way, but it's a bit smaller. It doesn't really have that aggregate storage place anymore, and overall it's just looking slightly differently. So at the start of the factory, there needs to be some place for unloading all the raw materials, and that's where I had to take some artistic liberty because I was not able to find some like close-up shots of that particular detail, and from the aerial views it really isn't all that clear. And it's actually only the Zwickau factory that I found that actually has some sort of facility for unloading at the very least, because some of the other factories, or all of them really, they didn't really have anything. They just have tracks and that's it. So I suppose that the aggregate was just dumped on the sides of the wagons and, I don't know, somehow scooped up, maybe with like front loaders or excavators or something, and just put into the storage in the bunkers. So yeah, this is what I built. I just built like a ditch on the side of that railway where it would probably be dumped into, and it has a conveyor belt that then moves it into the bunkers where it would be just sorted to put that in those respective bunkers. Now this is the bunker itself, and all these like overhead conveyor belts, that's what I'm kind of sure of because that was very much visible on the aerial views and even in some pictures. Now there is also a underground conveyor belt running below those bunkers so that when you need those specific aggregates, it somehow opens an opening in the middle of the bunker somehow, I don't know how, and puts or makes those, that particular sand just fall on it and transport it into that raised tower or into the tower, just tower, where the mixer is probably located. So there are many of these bunkers, as you can see, and they have different colors of the aggregate. Now, that is very much necessary because in real life, the different sizes of aggregate are usually also different materials. At least over here, they're very small find, the very small aggregate, small fine sizes are from quartz rocks, so they would be usually a bit more yellow, almost white, while the larger rocks are usually this like a gray. The conveyor belts are made from that pedestrian path, just like last time. This time I turned it with adaptive networks into this green roof configuration, and because it's a network, I'm able to put decals on top of it. So I used like a brown stain decal that's used for some iron ore maybe or something, but I basically made it look like it's a little bit rusted, right, the roof. So, you know, that's a nice little detail. The conveyor belts go into the tower with the mixer, then there is the factory. Like I said, I just use these DDR factory buildings, just put them together, and then after that we have the storage area. So I paid attention so that there are these like loading places for the panels. They would be in real life probably one way, so the trucks are just going to circle around the factory, and there is also the possibility to load panels onto railways to maybe transport them in different cities, different regions if they ordered those. So this was very satisfying to put together, because the quantity of these panels in this area, that's something really nice looking. And in real life, there's also many of these pictures of the panel factories focusing on those storage places. I suppose they are the most photogenic. There is this little bus stop in front of the factory for all the workers, and I would almost forget to explain what is that thing on the left right there. That would be the mixer for the fresh concrete transported outside of the factory into the construction site, because that was also necessary for the construction of the prefabs. So in here is just like the separate silos for cement and maybe some other admixtures, and the building with the mixer. It has a conveyor belt from the main storage of aggregates, so it doesn't need to have its own. There is also on that factory building that red banner with some kind of communist slogan and a red star to kind of remind us where we are in the series. Oh yeah, and by the way, I had to make those trucks, right, transporting the panels. So those are only props. I did not have any kind of like a semi-trailer truck like that, so I had to completely made it from scratch. So it's just a decoration in this area, but it looks okay. In the next episode, we will finally build some bigger housing estates with the prefabs, and like I mentioned, I would like to make the historical or technical backgrounds longer so we can go into more details. I would like to revisit that introduction to prefabs from a couple of episodes back and expand it, mention the underlying ideas, development, and so on. Anyway, that's it for today's episode. Big thanks to all the YouTube channel members who decided to directly support what I do here. Thank you. And if you would also like to become a channel member, there is the join button below or link in the description. That is all. Thank you for watching. Take care and goodbye.